Good evening, guys.
Good evening, sir.
Good evening. Let's wait for just two more minutes, then we will start. Okay. Okay, great. Let's start. So, guys, have you any doubt regarding last lecture? Any one of you?
No, no, from my side.
Okay. So, if you remember, guys, we were discussing about NAT, right? How we can configure static NAT on Cisco ASA. And today we are going to discuss about the packet flow as well, like what will be the packet flow on Cisco ASA. So that we are going to discuss. Okay, guys. So in last class we discussed about Cisco NAT on Cisco ASA, right? NAT on Cisco ASA. So we discussed we have two type of NAT, right? The first one is twice NAT, right? And the second is network object. So we know twice NAT actually used to translate with a single rule source and destination, right? So it can translate source and destination in single rule, right? That we discussed. And network object is actually used to translate only source address. Okay. So if we configure any rule using the network object, it can translate only source address. It can't translate the destination, right? Because always network object is created for the source addresses. For which address, guys? Source address. If you remember, this is the syntax to configure the network object on ASA. So we configure object network. We give the name is like my net rule or rule number one, right? And then we define here IP address, like IP address, the real IP address of my host. So maybe this IP address belongs to my server, so the server IP is suppose 10.3. Okay. And now I'm going to define here NAT, and we are going to do NAT 4. Now I'm giving here real interface. Okay. And after that we configure here a mapped interface. Mapped is suppose outside. Okay. And then we define we are using here static net, and we want to translate this IP address into this IP address. Okay. So let me draw a diagram, so then it will give you more clarity why I configure like this. So we have here one ASA. Here we have one client on internet. So suppose this is the client. Just okay, guys. Now here is the client, and here we have some servers. Okay, like this is the server. So server is located on my another zone, and this is my LAN zone where maybe I have multiple users to like this. Okay, so this is my inside network, and here I have outside network. So this is cloud. Okay, cool. Now just configure the name so you can remember ASA. Here we have inside zone. Okay, so this is for inside network, and after that we have here outside zone. Okay, toward the internet. And for servers, if you have any server, that is DMZ zone, demilitarized zone. Okay, if you check the definition, it will full form available on the internet. You can check. This is demilitarized zone, basically for servers. Okay, because we don't want anyone direct connect with your LAN network, because LAN network have different concept, or LAN network is for different purpose, right? To like a private network, but maybe you are giving some services, so you have some storage and servers, okay, in your network. So you will put all the devices in DMZ zone. So if anyone is on internet, like this client is on internet, right? This client is on internet, and client want to reach to your server, so it can reach. So you have separate rule to reach to data center, or you can see to your mini data center. Okay, so that's why we have here DMZ zone for that. And if you remember, we have here IP address post 30.3. Okay, and the client have IP address here, it's 20.2, and we have here gateway IP address is 20.10. Okay, so this is IP address on outside interface. So now what we did here, we configured a rule, and the rule is saying, so whenever this user is trying to move to the outside world, if this user is trying to move to the outside world, so the net rule says the real interface is your DMZ, okay, and the mapped interface is outside. So it will going to translate into 20.11. So now you can ask here question, how do you know DMZ is your real interface and outside is your mapped interface? So guys, if you remember the concept of real and the mapped interface, so real interface is where our source address is going to translate, right? And mapped interface is where destination is going to be changed, right? Destination address is going to be translated. So if you remember, we discussed in normal case, okay, in normal case, your client always try to access your resources, right? Those are available on the internet. So this client who is available in public network trying to access your services, right? Those are behind your firewall. So now this user is always going to send data to which IP address? So it will send like some data or data request. So source IP address is here 12.2, okay, and this is going to send to 11. Why? Because this is the public IP address, and they will hit on public IP address of your firewall. So firewall have here pool of IP addresses, okay. So now firewall is going to translate this 11 IP address into 30.1.1.3, because this is the rule. This is the rule, right? So now whenever traffic will come on your WAN port on ASA, so whenever traffic is hitting on WAN port, so WAN port is going to check the net rule. So net rule have here or you can say it will going to check your which table, guys? Escalate table. So in which there is entry 30.1.1.3 is going to translate into 11, right? So this is the translated IP address, and this is the real IP address. So now whenever traffic is hitting on the WAN port, so source IP is 20.2, okay, and the destination IP address is 20.11. So which IP address is going to translate here? Source IP or destination IP? Definitely destination IP is going to translate, right? So that means whenever destination IP address is going to translate on your this interface, so that means this interface is not real. Why? Because destination IP address always translate onto mapped interface. Onto which interface, guys? Mapped interface. Okay. So real interface is this one. Real interface is DMZ in that case. So this is our real interface. So that's why I defined here according to real interface. So this is our actual IP address, which is going to translate into 11. So that's why we configured here host. Host is our server IP address, right? So net rule is always according to the source. Why? Because do you remember object network object is always translate the source addresses. Which addresses, guys? Source addresses, not the destination. So in this net rule, who is the source? Who is the source, guys? This is the source, or this server is the source here? Who is the real source in this network topology? This is the real, right? So we configured here rule according to this server. Okay, so that's why we say object network is always going to translate source IP address. And if you remember, this is static net. So in static net is bidirectional. So we are using static net to translate the one to one, right? Normally one to one, or we have multiple options also. We will explore all the options. Okay, so the concept is clear to everyone, right, guys? I need your acknowledgement. Daniel, Kenil, Nandita.
Can you just go very small, just that side?
Okay, so
Thank you.
let me explain you again. So what I'm trying to say, the first point I explained here, the first point is network object is always used to translate the source address, right? Because we said twice net translate source and destination in a single rule, but network object can translate only source IP address in his role, right? In object role. So object role is always created according to the source device. Okay. So as we know, source IP address is going to change on which address? On real interface. So real interface, which means this is a real interface. But if I'm giving you the traffic flow idea, so in normal case, traffic is always coming from outside network or from internet, you can say, right? So now here is one user. So user IP address is 20.2, and user is trying to hit on this IP address dot 11, right? So whenever they are going to hit on dot 11, so user is going to hit on dot 11. So dot 11 belongs to subnet of your WAN port, because WAN port have 20.1.1.10 IP address. So 11 is also going to belong from the same subnet, right? So on this interface, ASA is getting here one hit, and ASA have translation table which have entry. In escalate table is have one entry, or you can say net table. So net table have one entry. Accordingly, 30.3 is going to translate into 11, 20.11, right? So that means this entry is permanent. This entry is, guys, permanent. Why it's permanent, guys? Because this is static net. This is static net. So static net entries always remain in the net table. Okay, so that is not going to be delete. Like if you have dynamic entries, they will disappear after some time, right? Accordingly, what timer is configured for net. But static entries always remain. So whenever anyone is going to hit on 20.11, so 20.11 is going to translate into 30.3. Okay, because if I have server in my network and I'm giving public services on this server, so any user who is available in public network try to hit on my WAN IP address, right? Because user always know my WAN IP address, not the LAN IP address, because LAN IP address is not routable on public network, as we know. So that's why we are using NAT concept. So they will hit on my public IP. So they are hitting on my one public IP 20.11, right? So if my firewall is receiving traffic for 20.11 on WAN port, that is going to translate 20.11 into 30.3 to the actual IP address of the server. So they can send data to server, right, after translation. So now in this case, ASA is going to translate the destination IP address. Which IP address, guys? Destination IP address. Okay. So destination IP address never translated in your object network, right? Because we are using here network object, and network object never translate the destination IP address. So what we need to do, we need to configure the rule according to the source IP address. So which is the source IP address here? Because this is not the actual interface. Why? Because this interface is translating destination IP address. So whenever any packet is coming to this interface, it's going to check the packet, and in IP header it is going to translate destination IP. So source IP is here 20.2, right? And destination IP is 20.11. So they are just translating this IP address into which IP? 30.3, right? So that means destination IP is going to be changed. So that means this interface is not your real interface. This is your mapped interface, guys. This is mapped interface. So you need to understand what is the meaning of mapped interface, what is the meaning of real interface. So accordingly, other interface is my real interface, right? So this is my real interface. Okay. Now I need to create rule. So object rule always says you need to create network object. Okay, any object. So you need to define here real IP address. You can't define here public IP address, right? So host or any network, or you can give here full network. We will see how we can give. But for now, I want to translate only one IP address. So I'm giving here my real IP of my host. Okay. And after that, I need to configure here real interface. Then I need to configure here mapped interface. And then I need to define I'm using static. Then I need to use here translated IP address. So that how we are going to configure the rule, right? So in this rule, see, I defined my actual IP address is 30.3. This is the actual IP address. And I'm going to translate this IP address into 20.11. So 20.11, that is subnet of outside interface. Okay. And here I need to define the real interface, which is my DMZ interface, which is my DMZ interface, and mapped is my outside interface, right? Mapped is my outside interface. So we always create network object according to real host or real network. So that is my point. Why? Because it's going to translate source IP address into this IP address. But we created static entry, so this is vice versa. So if anyone try to hit from WAN port, if anyone try to hit from WAN port from here to your WAN port. So still firewall is going to translate it. Why? Because static NAT is bidirectional. Static NAT is, guys, okay. So is it clear to everyone now, or is there any doubt? Daniel?
That's okay.
Okay, great. So now let me show you how we will do that. So just I changed here in my network. Okay. So we have here firewall, and this is my network of 12. Let me change the network even, because I'm using 20 term in example. Okay, I'm using a 20, and these are the loopbacks, and here we can use network of stop it. Don't need it anymore. Okay. So this is hard to for me. This is R3. Okay. So right now, I guess there is no configuration on firewall. So I will do that again. Okay. And let me configure here. So we have inside zone. Okay. Okay, leave the zone. Otherwise, you will be confused. So we have here inside network. And here is outside. This is DMZ. Okay. DMZ is for server. And here we have outside. And we are using here network of 30. Okay, R1. So I'm starting configuration with Cisco Firewall. We have first of all, I'm giving the host name ASA, interface gig 0 by 0, the LAN interface, no shutdown, name if is inside. So inside I have always by default security level 100, if you remember. And IP address is 10.10. So I'm using always 10 for every interface. Okay. And gig 0 by 1 is my WAN port. So name if is outside. Okay. Security level is 0. And IP address is 20.10. Interface gig 0 by 2, no shutdown. Name if DMZ. Security level 50. Okay. So I give security level 50 on this interface. IP address 30.10. So we configured all the interfaces of firewall. Okay. And let me write the configuration. So configuration will be there for the next time. Okay, so if I try to ping, the R3 is still not configured. Access the R2. Com R3. So we need to configure R3 because R2 and R1 have already configuration. Hostname is R3, interface ETH0/0, no shutdown. 30.1.1.3 because of the router number I'm using accordingly. And we need to give here one route so it can reach to anyone using this route. Okay, and I forget to enable transport input all login local. Okay, username admin privilege 15, password Cisco, IP HTTP, server IP HTTP, authentication local. Right, so we did all the configuration on R3. And on R2 also I need to change the IP address because this is R3 by default. If you remember, the host name is R2. Interface have it's now 20.2. Okay, yeah, good to go. So now check the reachability from ASA. 10.1 must reachable, 20.2 which is on outside, and 30.3. So everyone is reachable right now. So what I'm trying to do now, I'm going to configure on ASA. Okay, network object. So network object command is object network. Okay, you will give the rule or you can give any name. So for, okay, let me give rule number 1. And I'm going for a single host right now. Maybe I have multiple server, but we will come on that also. So I'm using a static net, and in static net this is one-to-one translation. Okay, so one-to-one is for my 30. So this is my real host IP address. Now you need to define here real interface and mapped interface. Okay, so method is static and we want to translate into this IP address. So outside interface have .10 IP, but we are using .11. Why? Because we never use the same IP address for translation. Okay, and if you check, still there is no any connection yet. Okay, and even there is no translation in escalate table. So there is just static entry, but translation is not here. So we have net rule for from DMG to outside. So if you check, rule is always from DMG to outside visible. Why? Because source is your DMG and destination is your outside. That's why. Okay, flag as, that means the rule is static, right? So if you check show net, so we have this policy. So guys, we have here 3 sections in net configuration. So right now we are discussing about here section 2. So section 1 is for actually twice net, section 2 is for network object, and we have here one more section, section 3, which is AutoNet. So what is AutoNet, that we will also discuss. So basically if you talk about, wait, okay, so the NAT is actually into section part, and accordingly ASA check the rule. Okay, so we have section 1. So section 1 is for twice NAT. Okay, and if we talk about section 2, that is for network object. And if we talk about section 3, section 3 is for AutoNet. Yeah, there was some name. Yeah, this is kind of AutoNet. Okay, so we use here some AutoNet definition with it. So right now, if we talk about, we are using here object network. So we are talking about here section 2. Okay, so that is net type currently. Now, if you check, we have here rule number 1. So that is DMG to outside network. So that is going to translate your source address, and entry is your static, and we are going to translate into 20.11. 20.11 is the translated IP address. Translation hits means if traffic is initiated from real interface, like if traffic is initiated by the server, so for the first time traffic will hit on the interface of ASA, and it's going to translate the source IP address into 20.11. So if I try to show you, we never do that because traffic always initiate from the WAN interface in this case. But if you try, like if we try to telnet 20.2, so telnet connection is initiated. See, we have here one hit on this, right? Translate hits. So that means traffic initiated from your real interface, not from the mapped interface. If any user try to hit from WAN port, and that will come to WAN interface. Okay, so in that case we will get hit count here. Okay, so if you check, we have here now entry in the escalate also, or you can check show connection. Not right now, maybe the connection is not stable because of telnet. Maybe the traffic is dropped, telnet is not enabled, or there can be any reason. Wait a minute. Yeah, we have, but problem is with R2, I guess. Yeah, because I forget to configure here static route because we changed the IP. That's why. So there was, okay. So if you try this time, it will make your telnet session. Okay, we have here, and now you can check here connection table also. So connection table also have entry, so this will remain your entry. And if you check, we have u means up, that is for inbound, and that is for outbound, o for outbound, right? But last time if you check, there was b means if traffic is initiated from a lower security level. Okay, and you can check with sock on long command will show you in which IP address this is translated. So this is TCP connection towards your outside on to IP address 20.2 on port number 23. Okay, and our user initiated connection from DMZ with this source port number and translated into 20.11, right? So that is initiated from the real interface. Okay, and if you check show net, so we have here two hit this time, right? So let me do one thing, let me close the connection, and if I check, show con, so now entry is no more, right? So now what I can do, I can initiate connection from R, not from R3 guys, from R2, because we want to initiate the connection from R2. So in this case, will my connection initiated or not? If I try to tell it to IP address 11, so it will initiate the connection or not? Or is there any problem? Guys, anyone have idea? Okay. So how we can verify why the connection is dropped? Could you tell me? Any one of you? Daniel, Kennel, Vicky, Siva, Nandita. Because we discussed the same point already. Okay, what is the traffic flow on ASA? Okay. Okay, guys. So if we don't know why the traffic is dropped, so there is simple idea. And what is that idea? We have some simulation command on Cisco Firewall. Using those, we can check why the traffic is dropped. And what are those commands? Please focus on that. So these are very helpful command. So you can use an ASS packet tracer command. Okay. So packet tracer means you want to trace the packet like that is generated by ASA itself, and it will check all the criteria to pass the traffic through it, right? So I'm just generating some packet from firewall itself. Okay, so we want input means you want to receive the traffic from which interface? Outside interface. What kind of traffic, guys? We want to receive TCP traffic. Okay, and after that we want to define the IP address, like the source IP address is 20.2, and on port number 102.4 or 5, any random port number, right? And what is the destination IP address? 20.11. Wait a minute. Yeah, 20.11. Okay. And 20.11 on port number 23, right? So it will show you, it's going to check first of all access list, MAC access list actually. So we no need to worry about it because we are not using, right? So now in traffic flow, it's going to check first of all NAT, and we are using a static NAT, and that is using object network rule 1, in which NAT, DMZ outside and static entries, that is going to translate with 20.11. Yeah, so they are going to untranslate it. So that means 20.11 is going to translate into 30.3 in that case, right? And now after that, NAT connection is allowed. There is no problem in NAT role. NAT role is allowed, but after NAT, firewall going to check ACL. So ACL is dropped. Why? Because traffic is coming on lower security level interface and moving to higher security level interface. So there is no access list for that. There is no access list for that. And action is dropped. That's why you can check. Oh, sure. ASP drop also you can check. See, the flow is denied by the configuration rule ACL drop because of the global policy. It will deny the three-way handshake, right? So what we need to do, if you remember, we need to configure ACL for that, right? What do we need to, guys? We need to configure the access list. Okay. We need to permit TCP traffic, which is coming for which IP address, guys? So if you want to configure the ACL, ACL is always for the real IP address. Okay. ACL for the real IP address. If this is clear to everyone, we can start discussion of traffic flow. Okay, so we applied the ACL. Now if R2 is going to do telnet connection, yeah, the traffic is allowed and accessible through it. So now you can check here, show con. Okay, So now see, so this is translated and now flag is B. B means traffic is initiated from outside. Okay. And there is one more thing. Now we have entry here and we also have here static entry this time. So whenever traffic is going back, to ASA, so why the translation hits not increased here? Why? Any idea? Guys, because if this user is trying to access the R3, so R3 must sending data back to firewall, okay, like the telnet data. So why we don't have any hit here? Show net. Forget this one. This is because of the last entry. But now we have here hits, right? If I close, it will increase, but this will not increase because there is no hit. So let me do that. Remove it. Do the talent connection again. Okay. And if you check on ASA, the entries increased. Entries increased for untranslated hits. So try to understand my point. Why traffic is not matching with the translation? Why? Because the traffic is also sending from the higher security level to lower security level, right? So the translate means when traffic generate from higher to lower, okay, and untranslate means when traffic generate from lower to higher. That is because if once traffic is coming from lower to higher and that is passed because of your policy rules ACL and net, so then when traffic is moving back through ASA, that is always check the connection table, not the net rules. That's why traffic is not matched with the net every time. Is it clear, everyone? Okay, so I hope this is clear to everyone. If you have doubt, please you can ask. Okay, cool. Hmm. So you can do even the packet tracer command. Okay, so we can use the same command. Packet tracer input outside. That means we want to receive traffic from outside interface. TCP traffic from source IP is this. Okay, and the port number is this is the random port number, and the destination IP address is 11 and the port number 23. So you can check. Okay, these are the all steps. So let me show you from here. So first of all, it's going to check the net. Okay, and here we have now net translation. After that, it's going to check the ACL, which ACL is configured by us, right? This is the ACL. So ACL is also allowed. After that, it's going to check some RFP check. We will discuss later about what is RFP. Okay. So that means traffic is allowed. Right? So that how you can check. So if this is clear, now I want to discuss something about actual packet flow on ASA. So what is the actual packet flow, guys? Okay. So actual packet flow means whenever traffic is coming, right? So if we have traffic, so that is ingress traffic for us, right? So in ingress traffic is coming on the interface. So it will like traffic is receiving on the interface first, okay? And after that, they are going to increase the counter, right? Increase the count on interface, like how many bytes of data received on the interface. Are you getting my point? So when that is increased, they are going to check next connection table. What they are going to check? Connection entry into connection table. So that means if any traffic is coming on my interface, so first traffic will receive on the interface, and at the same moment interface increase the counts of bytes, like this amount of bytes received on my interface. Okay, and after this, the first firewall always check the connection table. Why? Because maybe the traffic is part of current connection or existing connection, right? That is the reason. So if traffic is not part of the exit connection, existing connection, so that is going to be check destination net, guys. What it's going to be check? Destination net. Okay. So now you will ask here, if you remember, we discussed first of all firewall going to check the connection table. After that, firewall going to check routing table. What it's going to be check, guys? Routing table. But this time you have not mentioned about anything for routing table. Why? Because firewall always get to know about your exit interface through destination net, through destination net, because in destination net you know which is your exit interface, which is your exit interface. So it will give you information about exit interface, and exit interface means this is the interface from where you will reach your route, you will reach your route, right? So after that, if you have checked that destination net, what you are going to check? The next is
The source.
access list. So after destination, there is access list. If you remember, in our configuration, we configured the ACL for real IP address. We configured the ACL for, guys, because you can check this is the destination net for me. Why? Because traffic is initiated from the outside, right? So in outside interface, firewall translate the destination IP address, not the source IP address. So that's why I mentioned here destination net, right? So destination net automatically tells you about the exit interface. Why? Because if you check in the destination rule, see, so this is the static net. Static net is saying net from DMG to outside statically for this IP address, right? So that means the IP address 30.1.1.3 going to translate into this. But traffic is coming from outside interface, right? So when traffic is coming from outside interface, firewall match with the destination NAT. Destination NAT means now 20.11 is going to translate into 30.3. So that means now it's no 30.3 interface is DMZ interface. So NAT rule is giving you idea about the exit interface, right? So at that time, NAT divert traffic on your egress interface DMZ. On your which interface, guys? Egress interface DMZ. So in this diagram, so whenever traffic is initiated from this router, so router is initiating traffic for 20.20.11. Let me, okay, actually I have one problem. Mhm. Just a minute. Seriously. Okay. Now, see, so what we did. So the user initiated traffic from here on your WAN port, right? So this is your WAN port. So they are hitting to this destination IP address on WAN 20.11, right? So that means firewall is going to translate this destination IP this time. So destination IP address 11 is going to translate into 30.3 IP address, right? So that means whenever firewall is going to translate the destination net, so in that automatically get to know what is my exit interface. What is my exit interface? So this IP belongs to which interface, guys? Repeat with me, DMZ. DMZ interface, right? So that means exit interface is DMZ, and you can see the firewall is clearly saying the same point. NAT divert to egress interface DMZ. Why? Because traffic is for 20.11 IP address, which is translated to 30.3. See, untranslate, that means the reverse translate, right? So the reverse translate is from 20.11 to 30.3 IP address. So automatically from this translation, firewall get to know this is my egress interface. The DMZ is my egress interface, right? So that means there is no requirement to check the routing table. So through destination net, I will write down this line here. Okay. So just so you can make the notes. Okay. So ASA get to know about exit interface from untranslate net. Okay. Or you can say from destination net. Write down it as a destination net. Okay. So ASA get to know about exit interface from destination net. So no need to check the routing table. Why? Because you get to know automatically. Because if you know this is my exit interface, then why you need to check routing table? Okay. So in this firewall untranslate 20.11 IP address into 30.3 IP address. So that means 30.3 IP address interface is exit point for ASA, right? To reach the host. Are you getting my point? So that means that's why ASA no need routing table. No need routing table, right? So that's why what I mentioned here. So the point is still same. ASA first of all going to check the connection table. If entry is not there, then ASA going to check the destination net. So in ASA did this translation for me. So when traffic is hitting for this 11 IP address on WAN port, it's going to untranslate into this real IP address, right? So from this real IP address, ASA knows, okay, this is the exit interface, this is the exit interface, right? So now firewall automatically check the routing table through destination net. So there is no specific requirement to check routing table again. So now ASA can check the access list next. What ASA can check the access list? Okay, ASA can check access lists after the destination net. But uh, you need to be make sure, or you need to be keep this thing in mind. ACL is always for real IP address. ACL is always for real IP address. So real IP address is this. Okay. Real IP and 11 is mapped IP. 11 is mapped IP. I hope this is clear to everyone, guys. So whenever ASA is going to do destination net, it will untranslate the entry, because translation is from real to mapped. This is the translation, and untranslation is from mapped to real. Okay. So if you go with the ASA terminology, and after that ASA going to check the ACL which we applied. So we applied for real IP address, not for the mapped IP address. Is it clear? Guys, are you with me? Please, you can ask if you have doubts. Sankar, is it clear to you? Daniel?
It's okay, Prof.
Okay. It's okay means, is it not clear or like you are good?
You know, the whole idea is to get a concept. You know, you get
Yeah.
the
Yeah,
understanding, and the
yeah.
rest.
Just I want to
Yeah,
make
that's
sure
what
you
it's
know the
about.
concept because you can
Yeah,
configure the commands. I know that, right?
exactly. Yeah,
Yeah, but you need to know the concept.
the concept. Yeah, that's what is
Yeah.
important.
And Kenel, is it clear to you also, or do you have any confusion?
No,
Because
it's clear. It's clear.
okay, Nandita, okay, Siva, Siva Reddy,
Yes, yes.
okay, and Vicky Chopra, to both of you. Okay, cool. So guys, if you know the packet flow of Cisco ASA, so you automatically get to know the packet flow of other firewalls as well because they have majorly small differences in their framework, right? So if you go with Palo Alto or Fortinet, so maybe there are small changes, but actual packet flow remains same. Like how WAN firewall is going to check ACL, WAN firewall is going to check NAT, WAN firewall is going to check routing, or firewall is going to check inspection, right? So these are the main component of a framework. So maybe they have just small changes. Okay, if you check, but if you know the Cisco firewall, so it will be more easy for you to understand any firewall because I think Cisco have bit complex packet flow. Okay, but this is not much complex. Just a minute. Okay. So now firewall is forwarding traffic to interface. Interface it will increase the count. Okay, and then firewall check the connection table. If connection table have entry, then it's not going to check destination net and access list. It's going to come with directly inspection. Okay, but if there is no entry in connection table, I'm moving with like the entry is for the first time or the traffic is coming for the first time, so there will be no entry in connection table. Okay, so now firewall is moving with the destination net first, so it will check the destination net, and destination net gives you idea about exit interface, so routing table is not required to be checked here. And after translation, or you can say the translation or untranslation, it can be anything. Okay, now access list will be checked the next, and access list is always for the real IP address. Make sure always for the real IP address, right? So after that, firewall is going to check. Now the ACL is here, so firewall check. The next thing is, what is the next point in packet flow? Inspection. What is that, guys? Inspection, right? So firewall check here inspection. And you know, guys, what is inspection? Inspection means like you want to inspect any type, any layer 7 traffic. So if you remember, we inspected the telnet traffic, like we make it maximum connections like this, right? Okay. So after layer 7 inspection, now traffic will move to source net, right? So here we have now source net. So destination net will be happen here after destination ACL and layer 7 inspection. Then device is going to check for source net if device need to perform the source net. Okay, so it will be check here. Okay, So after source net, what next? Traffic will forward virtually. Traffic will forward virtually on your egress interface. So now, like whatever traffic you have, that will send on your egress interface, but virtually. Now, what is the meaning of virtual here? What is the meaning of that? Virtually traffic will forward on egress interface. Any idea about it, guys? Okay, virtually means, let me explain about it. So, guys, have you heard about this term? Okay, let me put with it interface. Interface queue. You know queue. What is the meaning of queue? So every interface have multiple logical queues. Queues are means like where traffic is going to be put, and after that traffic will forward on your physical media. So that means like there are multiple queues and they put the traffic in queue, the logical interface. So queues are basically logical lines where they put that data one by one, right? So that means like you have here multiple queue like this. Okay, these are the multiple queues for interface. Okay, 3 to 4 queues, and now they are going to put here data one by one, like here some data, here some data, here some data, like this. Okay, so that means after that data will move to your physical interface, which is here, like this is the physical media. So once they put the data on logical interface, and logical interface later on pass the data on your physical media. So if you ever learned about quality of service concept, so in that you will get about these terms, right? Because every interface have ingress and egress queue. So they have ingress and egress queue. So before putting data on real media, like on your Ethernet or fiber interface, so they always put data on your logical queues on router, and that is for both type of traffic, which is coming on the interface or which is going through the interface to outside. Okay, so this is for both type of data. So that time traffic is part of this queue. So that is trying to explain here virtually on egress interface. So virtually on egress interface means the traffic is inside the queue. Traffic is inside the queue. That is the meaning of virtually on egress interface. Are you getting my point, guys? Okay. So I think this is clear to everyone. Connection table, destination net, ACL, layer 7 inspection, source net. After source net, traffic will pass to your interface, but not the physical interface, the logical, which is queue. So traffic will put inside the queue. After queue, they will do on physical media, right? And now, after that, traffic will hand over the. Okay, after this, once traffic is available here, firewall do interface route lookup. Route lookup. What firewall do? Interface route lookup. What is the meaning of interface route lookup, guys? Because one is route lookup, which is done by the destination net, right? Now we have here interface route lookup. What is this interface route lookup? Okay, let me explain you. We have this diagram here, right? So this is our diagram. Okay, and now try to understand. Now firewall, okay, firewall is receiving any traffic on your outside interface, but this time not for 30 IP address. maybe you have some loopbacks here, like loopback is 333 or something like this. Okay, so this time firewall need route to reach these routes. Firewall need route to these routes, and firewall don't have exact route to reach these routes. So to check this thing, firewall need interface route lookup. Firewall need interface route lookup. Okay, I will show you how that works. Just for now, just understand this is part of packet flow. Okay, but I will explain you with practical how this thing is working. Okay, and the next point is, now traffic will put into egress interface or egress queue. Okay, so now this is part of egress queue. Egress means, you can say, the hardware we are talking about this time, hardware. So now traffic is put on hardware interface so they can forward it. Okay, but before that they will verify one more point here. And what is that? They are going to check layer to next hop lookup. What it is? Layer to next hop lookup. What is layer to next hop lookup, guys? Now layer to next hop lookup means firewall check the layer to MAC address, like is layer to MAC address available for this route or for this next hop, because maybe you have some problem to resolve the ARP, right? So that also verified by the firewall. And after that traffic will move to on physical media, or you can say traffic will exit the interface. Traffic will exit the interface. So guys, now did you get my point? Like, what is the packet flow here, everyone?
Can you take it from the interface route lookup again?
Yeah, I will show you
Yes.
with practical. Just a moment. Just I'm asking, did you get a normal idea about it, like the steps, how firewall is going to check everything? Okay.
Yeah, it seems okay.
One by one.
Okay, so first of all, like we know already about the destination net, which we configured, right? And even we configured the ACL, right? So now I'm moving with the inspection. So I am going to add inspection also in this. Okay, so we can see how firewall is going to check that, right? So we need to add inspection. So we have, okay, let me configure the things again. So just I'm going to remove everything. Clear configuration, access list, clear configuration, NAT, and object network, not the group. Okay, so let me check, is there any configuration pending now? NAT is not here. Show run object group is not here. Network object, right? But this command is not the right one. Okay, so there is no configuration. So let me start with the first of all NAT configuration. Okay, so this time I'm going to configure NAT for, I'm going to configure some loopbacks here. Okay, I will remove the loopbacks and configure here these two loopbacks. Okay, so I will remove it from R2. Now interface loopback 1, loopback 2, R3. I need to write down the configuration so it will not be visible for the next time. Interface loopback 1, IP address. Interface loopback 2, Okay. So we configured on R3. So if you remember, firewall also need routes, right? To reach that, not the outside. It's the DMZ interface. And the route is this one. Next up is this IP address, right? So we configured that. So now ASA have route in routing table. Okay. And even you want to check it, yeah, it's reachable. So now I want to configure first of all NAT role. So we need to define object network. Okay. Role number one, host. So this time my host is 333, right? I want to configure NAT for my DMZ interface. Okay. And the map is outside static, and I want to use 11 IP address. Okay. So NAT role is configured. So we need second ACL. So I want to use access list as my task one. Permit TCP any for host, the real IP address, the port number 23, and access list task one, not the access list, my bad. Access group task one in interface outside. Okay. So we configured ACL also. Now I want to inspect the telnet traffic. What I want to inspect, guys? Telnet traffic. So what we need to do, we need to configure first of all ACL to inspect to match the
Wait, Prof, please cool down. What's the name? The object, the network object, the NAT that you are doing at the network. I'm just a bit confused. You did NAT into bracket DMZ outside.
Yeah.
Okay.
So that means if anyone try to hit on this IP address on my firewall untranslate this IP into 333, which is now loopback of R3. If you check, so R3 have two loopback 333 and 3334. So
Okay.
this R2 is going to hit on 20.11. 20.11 is going to translate into 3333, right? So we configured NAT role first. Second, I configured the ACL. Like if anyone is coming on this interface with TCP traffic to destination IP address 333, you must allow that. And this is the ACL.
Sure.
So this is the ACL. So if anyone coming with TCP traffic for 333,
Yeah,
allow
for the
it.
ACL side, I get that side. It was just this side.
Okay.
Oh,
So
thanks.
I did two things. I configured destination NAT, okay, for outside interface. I configured ACL also, and now I want to inspect the traffic, right? So I want to inspect my telnet data. Okay, tel permit TCP any and port number 23, right? And now I want to use class map. Class map is like CMAP. Access group is my tel. Okay. Wait. I did something wrong. Inside the class map, I need to match access list tel. Okay. This is the command. And now we need to move into the policy map. Policy map name can be anything, just for now, keep it pmap. Class is CMAP. And what we want to do? We want to set connection con max 1. Okay. So this what I set. And now just a minute. Okay. Service policy. Guys, am I audible?
Yeah, you're fine.
service policy, PMAP, interface outside, right? So we applied the policy on outside interface. Okay. So we just configured three things: a net rule, ACL, and inspection, right? So now if you want to check on ASA, so we can check with packet tracer command. So we can see the traffic flow. Input outside interface, okay. Traffic will be TCP, and the user is 2 with this port number, okay, coming for 20.11 and port number 23. Okay.
The direct, please wait. The direction of the service policy. You just said outside.
No, input
No,
means
no.
the traffic is coming. The interface is outside. So that means traffic is coming from outside interface
Okay.
using
Okay.
TCP protocol,
That's
source IP and
yeah.
source port number, destination IP and destination port number. Okay. So first of all, this is for the first time for firewall. So that is going to check the access list, okay, and going to untranslate. And with this destination role, it will check, okay, the exit interface is DMZ for me. And after that, okay, the ACL is here. So it will check the access list. Access list is task one in direction from interface outside, and which is permitting any traffic for TCP destination 333, right? On port number 23, the destination port number. And later on, it's going to check the connect, you can say layer 7 inspection. So in layer 7 inspection, traffic is allowed because we have class map CMAP, which is matching the telnet ACL, which have telnet data. And now we set here con max 1, right? So that means maximum connection is 1. Okay. So traffic is also passed, so it will check all the criteria, right? So if we have configured the policy, so that's why it's visible here in packet tracer command. Okay. Is that clear?
Yeah, seems okay.
Okay. So now we did these steps like layer 7 inspection. So source net we will talk later when we will go on twice net, because right now we are using just one net configuration, right? But now the point is here, traffic is forward virtually on the egress interface, no problem. Now how we can make sure about interface route lookup? Interface route lookup is whenever we put route on firewall for the destination network. Just a minute. Now, on this firewall, we put route for 3333. Suppose I configure the route on ASA, but I misconfigured the next hop, because next hop is right now 30.3, the IP address of R3. And suppose I misconfigure that IP, I configure on route 30.30, which is not even existing anywhere, right? So that time even firewall will not able to check the route. Okay. So let me change this one. Show run route. So I'm going to remove this one. Okay. And now I'm going to paste it, and I'm going to change here IP. So now I configured route on R3. If you want to reach on 333, move to next hop 30.30, right? But you know 30.30 is not exist anywhere, right? So if you try this time the same command, the packet tracer command, guys, okay? So your traffic is not dropped anywhere. If you check, let me show you. I did the same command again, okay? So traffic is checked through the net rule, and even get the idea traffic must forward to DMZ. And now they check the access list, okay, there is no problem. And now traffic passed through the inspection engine, okay, everything is good. But you can check the traffic is ultimated past, there is no drop in traffic. So this is problem with your packet tracer command. If you try from r2, if you try from r2 to take telnet of 20.11, so you will not get telnet connection. Why? Because firewall don't have exact next hop to reach 333, because next hop is misconfigured this time. So how could you check now? So we can do one thing, we can use here logging enable, logging console 7. So now let me try again. Come on, it will take some time. Okay, the connection is stayed out. Let me try again. Mhm. Is it not giving me that log? Why? Okay, just a minute. So we are using, okay, this packet flow and exit connection NAT stateful, okay, egress interface. And here we have interface route lookup. So once at egress interface and egress and interface route lookup is performed, okay, so once traffic reach to egress interface here, so only routes joining out the egress interface are eligible. So remember, net role can forward the packet to egress interface even though the routing table may point to a different interface. So that means net rule, if you configure maybe wrong net rule, still they will forward traffic to exit interface, but that will be not visible in your packet tracer command. Okay, so if the destination is not routable of the identified egress interface, packet will drop. So that is happening in our case. And ASA must generate this log message: routing failed to locate the next hop. So what I can do, I have to do one thing, I guess, because they have already connections and everything, and I'm not getting the exact error. So clear con, okay, clear connection table, clear escalate. Okay, so I deleted all the entries. Let me try to generate the traffic again. But maybe this can be again difference on iOS because this is virtual. So maybe we will not get that log message, that what I'm trying to look up. Yeah, the log message is not coming. Yeah, but this log will visible definitely if you enable the logs on a real firewall. Okay, if you try on the firewall, you will see the log messages. Okay, but again we are using virtual and the platform is bit different, for sometimes this is difficult. So you can check if next hop is not reachable, because there is no such IP address like this. Sorry, not this IP, the 30. So 30 is there, no IP address. Why? Because there is no one 30.30. So that's why traffic is dropped, and even ASA can notify if you check on real ASA. Okay. Is it clear to everyone? Guys, No. Maybe I'm doing something wrong. Just a minute. Okay, let me do one thing. Actually, I think I need to remove the route. That's why. Okay, let me remove the route. Okay, then we will check. If route is not here, maybe this time we will see. Okay, so what ASA will do? ASA will put the traffic on egress interface using the destination net as we discussed. But if there is no route on ASA, because if you check, still packet tracer command will work, I guess. Where is the command? Yeah, this is the command. Okay, and you can see the traffic is still allowed, right? Traffic is still allowed. Okay, so there is nothing, there is no problem according to the packet tracer command. But what I did, if you check, I removed the route from ASA, so there is no route about 3333. Okay, and now logs are enabled already on firewall. I'm trying to take talent this time, so there is no route. So this time it will give me the error. See, that what I'm looking for. So if you don't have route in routing table, still destination NAT forwards the traffic to egress interface, but router is failed to locate the next hop. So that is the reason. That's why firewall need to check here interface route lookup. Are you getting my point now? Because destination NAT's giving you idea about exit interface where you can go now, right? But firewall didn't verify that is this next hop reachable for me where I'm trying to forward the traffic. So that's why firewall have to perform this thing here, interface route lookup. So in interface route lookup, firewall is going to check is this route connected or reachable from my exit interface. Like firewall have this is the network, and yeah, here we have. So now firewall is going to check on this interface, are the 3.3.3.3 reachable from me from this interface, or do I have route or not? So these things are verified in your interface route lookup. Maybe you don't have any route to reach that destination. For that, firewall put your traffic from this interface to this interface logically, right? So firewall need to verify, okay, the translated IP address or route is reachable for me, or I have route entry in my routing table. So at that point, ASA will forward the traffic. Otherwise, it will give you this error. Routing table failed to locate the next hop. This is the next hop, right? Daniel, are you getting my point?
Yeah.
Okay. So if ASA don't have route, still your destination net forward the traffic. Still destination net forward the traffic. So that's why ASA have to separately verify is this route reachable to me or not. Again here, interface route lookup. Otherwise, this is not required if firewall checked in destination net about exit interface. But exit interface just maybe because of some wrong configuration, you will get exit interface, right? Maybe you configured the wrong rule or wrong interface in your rule, right? So at that time also ASC have to verify. So that's why they separately performing this task just to check for destination network is reachable from egress interface or not, or destination route is visible in routing table or not. Okay, so I think there is no doubt till this point, guys. If you have any doubt, please let me know, because we are discussing the points one by one. Okay. Kenil, Nandita, Siva, Vicky. Okay. So the next point is layer to next hop lookup. What is the meaning of layer to next hop lookup, guys? Okay, layer to next hop means in the same diagram. Okay, right now we don't have route. We don't have route. So what I'm going to put, I'm going to configure the route this time. Okay, so here we have this route which we removed the last time, but by mistake I configured the wrong next hop. By mistake I configured the wrong next hop. So if I have route but next hop is wrong, still your traffic will drop, right? Still traffic will drop. See, the route is now existing and even you have next hop and now the interface is DMZ. So again, if you try to do the packet tracer command on your outside interface from 20.2, okay, on a random port number, and destination is 20.11 on port number 23. Wait, I did something wrong. I need to define, I guess, protocol. Yeah, protocol. So now first of all they are going to check the NAT. Okay, NAT is good, so they will untranslate, you can see. Okay, and after that there is ACL. Okay, ACL is also good, there is no problem. Then they will look up for inspection. Layer 7 inspection is going on here. Okay, no problem. So packet tracer command will even not show you layer 2 problem also, but layer 3 problem you get through the logs. So even logs are not giving you layer 2 problem. If you try to do telnet again, okay, so last time we get information about route was not exist, but now route is exist, but you will not get the problem about next hop problem, layer to next hop problem. So for that you need to enable debug ARP. Okay, you need to debug the ARP, and now you can try again. Wait a minute, that is trying. So you can check ARP send ARP request build from 10.10. 10.10 is IP address of your firewall interface for 30.30, and there is problem with this. Why? Because firewall is not able to get MAC address of 30.30. Who is your next hop for 333? So that is the problem. So you can only check with this command. If you check here, okay, we checked about the layer 3. If we don't have route, okay, now we have problem with layer 2 address. So once a layer 3 route has been found, but the next hop IP address identified, that is not resolved. So we need to check, like, is there any problem with layer 2 traffic? So if layer 2 resolution fails, so there will be even no low syslog packets. Okay, so even logs will not show you that. So you need to debug the ARP. Okay, and it will show you like generating request is pending, generating request is pending. It will show you such type of message. So in our case, or let me do one thing. Come on. Clear? Con. Okay. Okay. Now let me try again. Yeah. See. So generating request for 30.30 at interface DMZ, and the ARP request for 30.30 still pending. So you will get this error only. You have wrong next hop. You have wrong next hop, guys. Okay. So I hope this is clear to everyone. So we just discussed the normal, not the normal. This is the complete packet flow. Just if we move with VPN, then we will add few more things in this packet flow. Okay, but you can say this is your 90% packet flow of ASA. If you have any doubt in this, just let me know, guys. Okay, so you can just go through the PDF. Let me show you. Okay, so they are just giving here example of TCP flow. We have source IP 10.9, source port is random. Okay, destination IP is public IP, destination port number is 80. So the source interface is inside, destination is outside, right? So the traffic is coming from inside interface from this PC to a public server. Okay, so with this flow defined, explanation of configuration issue boiled down to just the two interfaces, interface inside and outside. Okay, so like first of all, traffic will come on your egress interface. So egress means like physical interface is receiving the packet, right? So that interface increase the counter on your NIC means interface, network interface card, right? And periodically revived by the CPU, so that will increase with time once traffic is receiving on the interface, right? So the traffic is coming on your outside interface in our case also. So we will see here software input queues. Okay, that indicate the packet of load, right? So we can check here overrun counter indicates packet drops. So that means if your queue is full, you will get increase on your overrun. Overrun means the virtual queue for the interface is getting fully, and now traffic is now start dropping. So you can check on your physical interface. Okay, so how we can check? Let me do one thing. No logging console. No logging enable, right? Show interface outside, right? So in outside interface, like this is your ingress. These are the packet, those counter increase and the bytes. And here you have one thing, where it is. This is the overrun. Overrun means if queue is full on this interface, traffic will start dropping, right? So these are the like points you need to make sure. If you will get any problem, or maybe you will get connection loss in your real infra, or you will see the slowness, so that can be the one reason the traffic is dropping again and again. And maybe that because of TCP, the device is generating same traffic multiple times, right? Because of the reliability. So that can be the one reason you need to make sure. And the second is after ingress, the traffic is coming to your connection table. So if you have already connection, so traffic will directly send for the inspection instead of destination net and instead of ACL. So if entry is already there, firewall will not check destination net and ACL. Okay, so firewall directly send data to inspection engine, because inspection will check every time if you have entry in the table. Okay, then your source net, egress interface, layer 3 route lookup, okay, and layer 2 route, address lookup also. Okay, so check first existing connection table. Okay, if entry exists, bypass ACL and process for the fast path. So that means if entry is there, they will do the fast path. Fast path means don't check ACL and destination net. Okay, so that is the command to check the entry. And if connection is not there, so they will do the slow path. That means session manager path. If you remember, we discussed about that. Okay, and once traffic is coming to after that, traffic will come for the destination net. So incoming packet will check with the net role. So we configure the net role, if you remember. Okay, If once traffic is translated, then the packet will check with ACL, because ACL is also required there, right? But in ASA version 8.2, ACL is checked for translated IP address, but in 8.3 it will check for real IP address. And there was one more thing. In 8.2, ACL was checked first and NAT was checked later. But now NAT is checked first, ACL checked later. So that's why ACL is checked for real IP address instead of uh, mapped IP address. Okay. And now after translation, your ACL will check. Okay. And once ACL is permitting your traffic will go for inspection. Otherwise traffic will drop here, if you remember, right? So if anything denied because of ACL, so that will not pass for inspection. And after that you have here layer 7 inspection, like stateful packet inspection protocol, TCP, UDP, ICMP. So that will check here. Okay. And after that, source net. Okay, we have not discussed yet about it completely. And after that, egress interface. So egress interface is receiving the traffic. Okay, here. So packet is virtually forwarded to egress interface, not forwarded to Ethernet NIC yet. Ethernet means they are not talking about the physical interface, they are talking about the logical interface. Okay. So egress interface is determined the first by the translation rules or existing connection entry. So that means now packet is moved to your queues. Okay, that is virtual forwarding. And after that we discussed about the layer 3 route lookup. Okay, so if you don't have route, so traffic will drop, and in logs you will get this message. Okay. And if route is there and you have wrong next hop, so that is check under layer 2 address lookups. Okay, so for that you need to debug the ARP, guys. Okay, if everything is good, traffic will forward for transmission on your egress physical interface. So that is entire packet flow of ASA. Guys, is that clear? Okay, Daniel, Nandita, Siva, Kenel. Okay, cool, guys. So I hope this lecture is clear to everyone. So now you can explain the packet flow, but there are few things still we need to discuss in depth. Okay, that we will discuss in upcoming lectures. I will configure like NAT to translate source and destination IP at the same time. So we will do that first of all through object network object role. Okay, then later on we will come to the twice net. But I think this is enough for the day. If you have any doubt till now, just let me know.